In this video, we're going to look at a slightly harder example involving a changing ratio. So we have a drink made with pineapple and mango juice in the ratio 4:1. Then 300 ml of mango juice is added, changing the ratio to 3:2. And the question is to work out how much drink we've got in total. So let's draw out what's happening first. The ratio starts at 4:1, and that's comparing the amount of pineapple juice with the amount of mango juice. So here they are, 4 bits to 1 bit. Now we add 300 ml of mango juice. So we'll draw another copy of that here, and then tack on the extra 300 ml of mango juice at the end. And now we've made a mess of all the bits down the bottom, okay, but we're told the ratio is actually now meant to be 3:2, which means our picture should actually look like this now. And what we're after is the total amount of drink we've got now. What makes this problem a little tricky at first is that we might think the starting point is to work with the 300. After all, that's the only real quantity we've been given. But why that's not such a good idea is that you can see right now we have no relationship between this 300 and the bits in our ratios. And by the time we've drawn everything, we've kind of lost track of where 300 fits into the picture. The main reason behind that is really that the bits in our two ratios are of different size. You can see that each bit in the bottom ratio is bigger than each bit in the top ratio. And while that's the case, we have no hope of establishing any relationship between the ratios before and after the extra mango juice was added. That suggests to us that the first step is actually to equalize the size of the bits in the two ratios. And the best way to do that is actually to focus on the part that hasn't changed, the pineapple juice part. Because we know it hasn't changed, we can most certainly equalize the bits between our ratios by making the yellow numbers, the 4 and the 3, equal the same number. Okay, so how do we do that? Well, we can control the number of bits in the ratios by multiplying both sides by the same number. And hopefully we know that both 4 and 3 can easily multiply into 12. So we're going to make that our target. So first, the ratio up top. How does 4 become 12? Well, it has to multiply by 3, so we're going to have to multiply the 1 by 3 as well, giving the ratio 12:3. Then the 1 down the bottom. How does 3 become 12? Well, it has to multiply by 4, so we're going to have to multiply the 2 by 4 as well, giving the ratio 12:8. So now that we've equalized the size of each bit across the two ratios, we expect we can make a lot more sense of the 300 ml of mango juice that was added, right? That change in quantity between the two situations there. More precisely, we see that 3 bits of mango juice became 8 bits. And we can meaningfully state that difference because we've made all the bits across the two ratios the same size, remember? And that means this 300 ml of mango juice here must be worth exactly 5 bits, the difference between 3 and 8. So then each bit must be 300 ml divided by 5, which is 60 ml. Okay, now we're after the total amount of drink, which means we need to know the amount of all of this stuff we've got now. So we've got 12 bits of pineapple juice and 8 bits of mango juice, giving 20 bits in total. So on the right, now that we know each bit is 60 ml, we can just take this 60 and multiply it by 20 to see the size of 20 bits. And we get 1200 ml. It might be more normal to write this in liters, so we can divide by 1000 to get 1.2 liters as our final answer. Okay, so let's quickly recap how we handled these changing ratios. We still aim to work out the size of each bit. That's still the main idea. Okay, again, the question was easy once we figured that out. But if we're needing to compare or see the relationship between two different ratios or track some change in quantity between two different ratios, we'd better make sure their bits are of equal size first. That's the only way we can fairly compare the two ratios. Often, the easiest way to do that is by thinking about what hasn't changed. So in this case, it was the amount of pineapple juice, which led us to try and multiply those yellow numbers into the same thing, the easiest target being the number 12 here. We fix the ratios by making sure we multiply the other number appropriately too. So in this case, the top one had to multiply by 3 and the bottom one by 4. Now we've made sure the bits between the ratios are equal in size by making the yellow numbers the same as they should be. We can meaningfully compare the orange numbers to see that 5 bits equals 300 mils. And once we were there, we could divide by 5 to work out the size of each bit. And then we could just multiply to get whatever quantity we're interested in. Okay, in this case, it was the total. So we just had to add up all the bits we ended up with, and that was 12 plus 8 giving 20, and so we just had to multiply the size of each bit by 20 to get our final answer. Okay, now for what it's worth, if I was answering this with pen and paper like you would be, my working would look almost exactly like this on the right here. Okay, again, the pictures were there for your understanding and for me to communicate that to you, but once you get the hang of what's going on, a lot of that reasoning really happens in your head, as you've probably seen already. You can still draw if you like, but you can see once the numbers get a bit bigger, drawing doesn't get as practically useful or helpful if the numbers are huge. Okay, so what you see here is much closer to what I'd be expecting you to write. Okay, so that's all for this one. Thanks for watching. See you later.